Good day and welcome to the Math Salon. I'm Dr. Animende. Today we are going to look at some advanced level questions on integration of trigonometric functions. Trigonometric functions and integration, these are things that come in one way or the other in paper 1, paper 2, and paper 3. So I think some tools and tricks that I'm going to show you can really come handy. So one of the things to look at here is the first question is the integral of cos to the power 3 of x sine to the power 3 of x dx. This integration. This is a good one in the sense that I have cosine and sine, and the derivative of one, is the other, except sometimes with the difference in sign. That means we can use substitution techniques. So how do you go about it? The key thing would be to make sure that we transfer the powers to one of the cosine to one of the trigonometric functions. So we can make sine to higher powers and leave this cos x to the first power, or do the same thing, get all the powers to cos x and leave sine. And how do we do that? We know very well that from our fundamental trigonometric identity, the sine squared of x plus cos squared of x is equal to 1. That means based on this, I can make cos x squared the subject of the formula, and I can make a substitution. First, let me fix this. We have here cos cube x sine cube x. This can be written as cos x times cos squared x sine cube x. And from this we see that cos squared x is equal to 1 minus sine squared x. So I can substitute my cos squared x here with this. If I do that, I get cosine of x into brackets 1 minus sine squared x times sine cube x. I can expand this expression, and what I get is cos x times 1 here is cos x times that is minus cos x sine squared x, all that multiplied by sine cube x. If I open this up, then I get cos x sine to the power 3 of x minus cos x. So this cos x times this is this one. Then this times that, this is cos x sine to the power 2 times sine to the power 3 sine to the power 5 x. I can take this and substitute in that integral. That means I can write this integral now as the integral of, I can replace this expression that we see on my left hand side with what I have on the right hand side as cos x sine cube x minus cos x sine to the power 5x, or the dx. In order to do that, of course, we can actually split out this integral. The integral is distributive with addition and subtraction, so this can become the integral of cos x sine cube x dx minus integral of cos x sine to the power 5 x dx. Once I've had it in this form which I indicated, you see my cosine is to the first power, sine to the third power, cosine to the first, then this is nice. We can just make a substitution. What we'll do, we'll let u to be equal to sine x. If we do that, then du is simply equal to cos x dx. Because I have this, I can then substitute it in here. So what I will do is my cos x dx is just du, and sine x is u, so this is u to the power 3. So this now will become the integral of u to the power 3 du, because my du is cos x dx, this cos x and this dx become du, and what is left is sine to the power 3, but sine x is u, minus the integral. I'll do the same here, cos x dx is du, and this is to the power 5. So that is that. And this is a simple integral to do. This is just u to the power 3 plus 1 divided by 3 plus 1. So this u to the power 4 on 4 minus u to the power 6 on 6 plus a constant, because this is an indefinite integral. So we have no limits. So we have to include a constant. But I was not giving u. This u, we can replace them back. We have let u to be equal to sine x. So what I can do here is I put that back. So this is sine to the power 4 of x on 4 minus sine to the power 6 of x on 6 plus a constant. So you see that in general, once you're able to fix it this way, it seems the integral is automatic. In general, then we can say if I have something like cos x sine to the power n of x dx, then this is simply equal to sine to the power n plus 1 divided by n plus 1 plus a constant. So that seems to be the general form. For the second part of the equation, I have an integral of cos to the power 5 of x dx. Now this one is not a product of two different trigonometric functions. It's just that of cosine alone. But we can play around with it and come up with a form that is like the one we just saw above. So to do that, we can trick this around. So this can be written as, I will split that is cos to the power 5, so I can write that the integral of cosine x times cosine to the fourth x. You see, this 5 has split into 1 here and 4. If I multiply this, I come back to this, just like we did when we were doing sine to the power 3 times sine to the power 2. So if that is the case, what I'm left to do now is just change this into sines so that I can get a mixture of cosine and sine. And then I will just apply the same technique as above. How do we do that? Dx here. So we go again, we use our fundamental idea. We had seen that cos square x is equal to 1 minus sine square x. So I can actually say this can be written as cosine of x times cosine squared of x, all that squared dx. Yes, because 2 times 2 then will be 4. So cosine squared times cosine squared is cosine to the fourth power. So if I do that, then this is simply the integral of cosine of x into 1 minus sine squared x, all that squared dx. I'm left to expand this out. A plus b, let me take a minus this case, minus b, all that squared is simply a squared minus 2ab plus b squared. So we will just do that for this expansion. So this is actually equal to the integral of cosine x into brackets 1, that is 1 squared, minus 2 times this 2, 1 times that is just sine squared, and the minus 2. So minus 2 sine squared x plus this term squared, so the b. So this squared becomes sine to the fourth power. So I can now open these brackets and I get here the integral of cosine x. So cosine this times that, minus 2 cosine x sine squared x plus cosine x sine to the fourth power of x, all that dx. See, we have them in that form. I can play with this one, the integral here. You just, I can also write this as sine to the power 0 if you want to do that, and you will still get the same version of what you need here. So we will see that you come back to that form once you split out your integral. I get the integral of cos x dx minus 2 integral of cos x sine squared x dx plus integral of cos x sine to the fourth x dx. We are back to the form that we had fixed this into. So you will just see that by the rule, this is simply going to be sine x here. This will be minus 2 here, sine x to the power 3 divided by 3 plus here sine to the fifth divided by 5 and a constant. So hope that that was understood. If you have some questions or missed something, please leave me a comment. Remember, of course, to subscribe, thumbs up, and share with your friends. Bye.